Okay, Ji. So we are starting with lecture number 2, differentiation. In the previous lecture, we made sure that we understand what is differentiation, and then we made sure that we understand the requirement of the topic with what the examiner will actually ask us. Now, since we are moving to differentiation lecture number 2, you need to understand that there are rules of derivatives. The rules of derivatives. Rule number 1, that if we differentiate variable with power, so that power will come down and multiply with the coefficient, and there would be one subtracted from the power. There would be one subtracted from the power, which means that if we have, for suppose, d upon dx, x cube, that we need to differentiate x cube, the power will come down and multiply with x, whereas 1 will be subtracted by a power. So 3 minus 1 will be 2. That means we need to understand the power 3 will have what? 3 minus 1, and you will get 2. Power comes down and multiplies, whereas 1 will be subtracted from the power. So 3x square is the differentiation of what? X cube. Moving on with another example, let's say we have d upon dx, and we write down as x square. So differentiation of x square will be 2x, because 2 will come down and multiply with x, whereas there would be minus 1 from 2. So we will be left with only 2x. Similarly, if we say that d upon dx, differentiate under root x. Now, this means that under root always tells us that the power is half. Under root always tells us that the power is half. So that means if we just write down this thing as x half, so we will be differentiating x to the power half. At this time, we have just converted the under root into the power. We have not differentiated yet. But if we differentiate it now, this will be 1 upon 2 x and minus 1 upon 2. Minus 1 upon 2. So that means that the power will be subtracted by 1, whereas the original power will come down and multiply. And 1, since 1 is subtracted, so 1 upon 2 minus 1 will be what? Minus 1 upon 2. So considering this, your answer is 1 upon 2x to the power negative half, but we are going to write this thing as 1 upon 2. Obviously, when my negative 1 upon 2 comes down, it will turn to positive. And we can always write this as 1 upon 2 under root x. So the differentiation of under root x is 1 upon 2 under root x. Let's do few more examples. D upon dx is 4x. So your answer to this will be directly, we can write this thing as 4, because the power here is 1. The power here is 1. 1 multiplied by 4 is 4. 1 minus 1 will become 0. So anything to the power 0 is basically 1. So considering this, the answer for 4x will be 4. Similarly, that means if we have d upon dx is equal to 8x, so for this, the answer would be 8. So whenever you have any coefficient with x, the differentiation to that value will be the coefficient itself, because the variable will have x to the power 0, which will convert to 1. Moving further, if I say that we have d upon dx and 7x cubed, so this will be 21x square, because the power comes down and multiplies. 7 3 is 21, and 3 minus 1 will come square. So the answer of 7x cube becomes 21x square. Let's just solve few more examples of this with the combined equation form. So if I say that we have d upon dx, let's say we have d upon dx, we need to differentiate 4 upon x minus 2x plus 5. So if we differentiate this, we can write this thing as d upon dx as 4x to the power minus 1 minus 2x plus 5. So when minus 1 comes down, this should be minus 4x to the power minus 2. Whereas 2x, differentiation of 2x will be what? 2. So the answer for this will be minus 2. So since we differentiated this, we can always write down the variable. If it is concerned with y, then it will be dy upon dx. But right now what we can do is, we can write down as minus 4x squared minus 2. Similarly, if I say that we have question that has d upon dx, 3 upon x squared plus 4 upon x plus 5 upon under root x. So if we need to differentiate this, that means we are going to write down the variable properly. That will be 3x to the power minus 2. Still we have not differentiated yet. 4x to the power minus 1 plus 5x to the power minus 1 upon 2. Because under root is half, half goes from denominator to numerator, it will be negative. Similarly, x when shifted from denominator to numerator, it will be negative. When x square shifted from denominator to numerator, it will be negative. So moving on, you need to understand when we differentiate, the power comes down and multiplies. So minus 2 into 3 becomes minus 6, x minus 3, because negative 2, negative 1 becomes negative 3. This should be minus 4x negative 2, whereas this should be minus 5 upon 2 x. Negative half minus 1 will turn down to negative 3 upon 2. Negative 3 upon 2. So we can always write this thing as negative 6 x cubed, negative 4 x squared, negative 5 upon 2 x to the power 3 upon 2. So differentiation of your 3 plus 3 upon x square plus 4 upon x plus 5 upon under root x will be minus 6 upon x cubed minus 4 upon x square minus 5 upon 2x to the power 3. So these were the examples, more examples from rule number 1. So let's just move to rule number 2. Your rule number 2, let's say d upon dx has to be multiplied by ax plus b to the power n, has to be differentiated. So that means your differentiation is with the bracket now. So when we differentiate the bracket, we need to understand that what do we have here? We have power and we have values in the bracket. So remember one thing, before doing anything to the bracket, we need to differentiate the power. And what will happen is your power will come down and multiply. You will obviously subtract 1 from the power. And then after doing the entire thing, then you will differentiate the bracket itself. So that means your power comes down, your n comes down, multiplies with the bracket. So this is ax plus b. Your bracket remains same because you need to differentiate the power first with -1. So this will become what? N minus 1. Now what you're going to do is you're going to differentiate your bracket values ax plus b. So the answer for this will be n ax plus b to the power n minus 1 multiply by a, which means your end result should be an ax plus b to the power n minus 1. So this becomes your second rule. So let's just do a few example questions of the second rule. Let's say d upon dx, we have 3x minus 1 to the power 4. So when we differentiate this, your 4 will come down, multiply, your bracket will remain same, and then you have 4 minus 1, which is 3. Then you multiply with the differentiation of the bracket, that is 3x minus 1. So you know that the differentiation of your 3x minus will become 3. Why? Because your value 3x has x. So this becomes 3 only. 3x to the power 1. 1 multiplies by 3 is 3. 1 minus 1 is 0. X to the power 0 will be 1. But the other constant number will become 0. Because if we have constant number, so we expect that we have x to the power 0 there. So for suppose 3 is there. So 3 has x to the power 0. When 0 comes down, multiplies with 3, it will become 0. So the constant is removed whenever we differentiate it. So that means if we have -1, it will be 0. If we have 7, it will be 0. If we have 5, it will be 0. So the end result for this question will be 4 into 3 will become 12. This is 3x minus 1 cube. So this will be your answer for 3x minus 1 to the power 4. Let's do another question. Example for this, d upon dx. Let's say we have 3 minus 2x to the power 5. So now when we differentiate this, we write down this thing as 5. Will obviously come down and multiply. 3 minus 2x to the power 4. And then obviously we need to differentiate the bracket. So d upon dx, 3 minus 2x, so which will be -2, because obviously the constant number 3 will become 0, whereas minus 2x differentiation will become what? -2. When 5 multiply by -2, we will get -10. So the answer for this should be -10, 3x minus 2x. I would correct this thing. We have 3 minus 2x to the power 4. So this would be the differentiation of 3 minus 2x to the power 5, which is -10, bracket open, 3 minus 2x to the power 4. Let's do another example. D upon dx, 4 upon 1 minus 2x, which is an under root. So let's just write this thing down. D upon dx, your under root becomes power half. So this should be in the numerator with what? -half. So now, when we further solve this, we know that your -1 upon 2, since it is the power, it should multiply with 4. And then your -1 upon 2 will be subtracted by -1. So the answer for this can be used as 4 minus 1 upon 2 multiply by 4, 1 minus 2x, and the power for this should be -3 upon 2. -3 upon 2. But the next step is you need to differentiate the bracket 1 minus 2x. So when we differentiate the bracket, this should be negative 1 upon 2 multiply by 4, or we can just directly use this as this becomes negative 2, 1 minus 2x to the power 3 upon 2, and this should multiply by differentiation of 1 is 0, whereas minus 2x will be negative 2x. So the end result for this is negative 2, negative 2. It will be negative 2. So the end result for negative 2, negative 2 should be 4. Whereas since the power is in negative, because obviously we can always shift it to positive as 1 minus 2x to the power 3 upon 2. And then this will be your answer for the given question. That means 4 upon under root 1 minus 2x will be written as what? 4 upon 1 minus 2x to the power 3 upon 2. So let's do another example of the question. 4 upon under root 4 upon x minus 1 plus 5 upon 2x plus 1 square. So let's just change this as d upon dx 4x negative 1 to the power negative 1 plus 5 2x plus 1 negative 2. Let's just do this in the direct method. We can always write down this thing as negative 4 x minus 1. This should be negative 2. And when we multiply, we'll be multiplying with the differential of the bracket. That will be x minus 1. The answer would be 1. Plus 5. This should turn down this value to negative 10. 2x plus 1 to the power negative 3. Multiply with 2. Because 2x plus 1 differential is 2. So the end result for this should be negative 4 upon x minus 1 whole square, negative 20 upon 2x plus 1 cube. So this will be your answer for the differentiation of 4 upon x minus 1 plus 5 upon 2x plus 1 whole square. So whenever there are two fractions, so you will be always using the differentiation method on both of them. You'll be solving them separately.